Hello everyone, today is day 50 of solving a LeetCode problem every day, so we are finally a third of the way there. And today I'm going to be solving finding the user's active minutes. So you are given the logs for user actions on LeetCode and an integer k. The logs are represented by a 2D integer array, logs, where each log is represented by another array which has the ID of that log and the time of that log. And so yeah, it basically says this indicates the user with the ID, and it indicates that an action was performed at the minute whatever gets passed into the array here. So multiple users can perform actions simultaneously, and a single user can perform multiple actions in the same minute. The user active minutes for a given user is defined as the number of unique minutes in which the user performed an action on LeetCode. A minute can only be counted once, even if multiple actions occur during it. So basically what this block says right here is that multiple users can perform actions simultaneously, meaning that two different users can perform an action at the same time. And it says a single user can perform multiple actions in the same minute, which means that we might get passed in the same ID alongside the same time twice, meaning that one user performed two actions in the same minute. But over here it tells us that the UAM is defined as the number of unique minutes in which the user performed an action on LeetCode, meaning that even though we might have multiple actions for the same user at the same time, we only count it once. So it tells us you're to calculate a one indexed array answer of size k, where we get passed in size k, such that for each j, where j is at minimum going to be 1 and at most going to be k, answer j is the number of users whose UAM equals j. So pretty much what it's saying is we're going to have a list of IDs, and for each ID, they're going to perform a certain amount. So they're going to have a certain value for the user active minutes. And we're essentially just going to create an output array where each position represents, so for example, like this output array here at index 0, that's going to represent 1 UAM. Index 1 is going to represent 2 UAM. So essentially, if we look at this as a one index based array, like each index just represents the amount of users who have that many user active minutes, where the user active minutes is equal to the current index. So this is how we are going to solve this problem. So for one, there are two things we need to track. The first thing we need to track is the user active minutes for each user, and the second thing we need to track is if a user has performed multiple actions in the same minute. And the reason why is because if we get passed in some type of action that has been performed in the same minute as another action, we don't want to increase the UAM for that user. We want to keep it the same. So to start out, we're going to create a dictionary called UAM, and this is just going to store the IDs alongside the UAMs for each ID. And then we're also going to create a past dictionary, and it's going to be a default dictionary where each value is going to be a set. And then finally, we're also going to create an output array, and our output array is just going to be of length k, where each position is initialized as a 0. We're then going to loop through all the logs, and we're going to grab the ID and the current minute from the logs. So we know that at index 0 of each array, we're going to be passed an ID, and we're going to be passed the time at index 1. And then we're going to check if that minute is in past. So we're going to check if this minute, so if an action has already occurred for this ID, and if it has, we're just going to continue. Otherwise, what we're going to do is to the past set, we're going to add that minute. And then in the UAM dictionary, for that current ID, we're going to basically just increment the UAM. So here we're going to get it. If it hasn't already been initialized, it's going to be initialized as a 0, and then we add 1 to it. So this right here basically just creates this dictionary here for us, and then we're going to loop through all the keys in the UAM, and then to the output, we are just going to pretty much create this output array. So we're at the output of the current index, so of the UAM. So we grab that key and we grab the value, so the actual UAM. And the reason we subtract by -1 is because the array is like, it starts at index 1 and not 0. And we just increment that by 1. And then finally, we just return output. So if I run this now, it accepts, and if I submit this, this accepts too. So the time complexity of this solution is going to be O of n, so it's going to run in linear time. And the reason why is because we just process, so we process each of these logs once, and then we also are going to loop through the keys. But I think that this step right here is actually unnecessary, because what I think we can do is just, or actually, I take that back. It might be unnecessary, but I'm not going to say that it's unnecessary, just because you do need to get these, I guess, these finalized UAMs before you can actually build this output array. But there might also be some way where you can just skip this step right here and do it directly within here. But yeah, so the time complexity is going to be linear, and then the space complexity is also going to be linear, since we have to create this UAM dictionary and this past dictionary. So yeah, that's my solution for the day.